Hello ladies and gentlemen, Mr. Miller here with our Algebra 3.1 notes. We're going to be getting into graphing and writing equations, looking at functions here, obviously in the first section, so that's what mainly we're going to be doing. So from this section here, you're going to determine whether relationships are functions. That's one thing that we're going to focus on. So determining whether our relationships that we're going to see here are functions. Second, we're going to find the domain and range of a function. Find domain and range of a function. And third, identify independent and dependent variables of a function. So identify independent and dependent variables of a function. So as usual here, I'm going to let you guys do your warm-ups by yourself here. Those answers will be posted. So try writing an expression here, 7 more than a number. Second one, determine if 3 is a solution of that 2x minus 4 equals 2. And then a little story problem here. George spends $4 more than twice as much as Casey at a store. If Casey spends $6, how much did George spend? So take a moment with those. See if you can get those. All right. So for our notes here, so I can get that a little nicer looking. A little bit. Kind of like to be able to see the whole sheet. All right, so for notes, the input and output table here shows the amount of money Miguel earns at his job for several numbers of hours. Identify the domain and range of the function. So our input, ladies and gentlemen, is the domain. So if we're identifying the domain, that is the input. So our domain is equal to the input, which is equal to hours. And that means the range, that's the output, because and we're going to get into this, it depends on the domain here. The range, that is the output, which is dollars. So you have to have, when you're looking at this in real world context, you have to have with the domain, it has to be something happening. So we don't get paid any money unless we put the hours in. So the hours have to be worked, and then the person gets paid for their hours worked there. So our domain, the input is the hours, and those numbers are, again, I'll just write them down here. Our domain are the following numbers: 2, 5, 7, and 8. And then our range are the following numbers: 14, 35, 49, and 56. Now, to tell if a function or I should say, if something is a function here, a couple ways that we can present it here. So we kind of have like a flow chart for the first one and then a regular table for the second one here. And we're trying to figure out, is this a function? For it to be a function, ladies and gentlemen, we have to have different inputs. We cannot have the same number for inputs. All right. You can have the same number for outputs. That's perfectly fine for a function. So for like this first one, first thing I'm going to look at is my input numbers. So I have 3, 4, 6, and 8. They are all different. That is great. And then our output, again, we could have 4 different numbers, or we could have, in this case, 3 different numbers because both the 4 and the 6 go towards the output. But this is still a function. So wherever you want to write that, this one is a function, all right, because we have all different inputs. For my table here, again, my inputs, my domain, we have to have different numbers. So we have 1, 2, 2, 4. So that is where it's failing. We have 2 2s. We cannot have that. So this is not a function. So again, very simple here. If it is going to be a function, we have to have a single, all the inputs have to be different. Outputs can be whatever, but all the inputs have to be different. If it's not a function, that's where we're going to have the same input multiple times. So it might be 2 2s, or I could have had maybe 2 4s in this, or maybe 2 1s, or they might have been all 4s. Could have multiple ones. It's going to fail also. Last question on this side here, and this question actually goes to the next one as well, so we'll look at that. But it says the domain of the function y equals x plus 4 is the following: 0, 2, 3, 6, and 7. Make a table for the function. Identify the range. All right. So a lot of times we do think of the domain, as the x value. So these are all our x values that we're putting into this. And now we're going to identify the range. The range is the output once you put that in. And this is kind of getting us into our independent and dependent also. The x is the independent, so those are the individual numbers we put in. The dependent is the y, because it depends on what x we're putting in here. We'll have another example of that also here in a second. So again, domain, think of it as your x's, and your range, your output, what is the final answer, what is the y in this question. And again, our variables can change, but we're dealing with obviously x and y in this one. So here, if we're making a table, I like to write down my equation first. Y equals x plus 4. So then we just make a table. If you want to put boundaries around your table, you can put boundaries around your table. I'm just going to save myself a little time. X's are going to go on for our inputs, and our inputs are 0, then 2, 3, 6, and 7. And then we have to do our calculation through our formula here. So plugging in 0, if I plug in 0, our output is going to be 4. If I plug in 2, we get 2 plus 4, so that's going to be an output of 6. 3 plus 4, output is 7. 6 plus 4, output of 10. And then 7 plus 4 is our output of 11. And then the last question says, identify the range. So my range are the following numbers: 4, 6, 7, 10, and 11. Like I said, my copy here, This is for the question on the back. Determine whether the relationship or relation is a function. So I need to turn my page over because it goes with this picture here. So I'm going to determine if it is a function. So again, I want to look at my inputs. 2, 3, 4, 5, and 6. Those are all different. That's good. So we have a function. Is a function. And again, doesn't matter what the outputs. The outputs can be repeated. Again, we have a 1 for 4 and a 1 for 6. That's fine. We have all individual inputs though. Vertical line test here is the relation represented by a graph is a function provided with no vertical line passing through more than one point on the graph. So here we have two graphs here, and again, vertical line goes north and south. So again, you might want to write yourself a little note there, north and south. That's our vertical line. So when I'm doing my vertical line, no matter what x coordinate we pick, we can only go through one single point. So if I happen to pick 6 here, and I do my vertical line test, we notice we have 2 points that we went through. So if we go through 2 points, that is not a function. So is not a function. Because again, on our table, if we did our table of this, we'd have 6 and 1, and then 6 and 2. Again, we cannot have 2 6s. Also fails on 2 as well as 1. Because we have 2 answers for 2, and we have 2 answers for 1. So is not a function, it fails. If we look at our second graph here, if I go with point first x, I only have 1 point. Second x, only 1 point on there. Third x, only 1, only 1, only 1, only 1. This is a function. Because we have an answer, a single answer for all of the different x's. So all of our inputs are different. So that is a function. Last one here says the function here, y equals a minus 3x plus 12, represents the amount y in fluid ounces of juice remaining in a bottle after you take x number of gulps. Identify the independent and the dependent variables. So the independent in this one, ladies and gentlemen, is the x. What we do, how many gulps we take determines how much liquid is left. All right, so our gulping in our formula here, so as we drink more, we're going to get less and less and less as you drink more. So our independent is the gulps. So we can change that. We could take only 1 gulp, or we could take 4 gulps. All right. The dependent, that is our y. That tells us how many fluid ounces are left. So, question B, after we've identified those, you can take 0, 1, 2, 3, or 4 gulps from this bottle. What is the domain of the function? So again, you heard me say this earlier. Domain, ladies and gentlemen, is the independent. So domain is independent. So the domain of this function is that x that we're looking for. And what is the range? Now we want actual numbers here, so we're going to have to set up a table as well. And range is the dependent. So independent, domain, dependent, range. So the range depends on the domain answer here. So very similar. You can set up a table here as well, but we're going to be doing a lot of plugging in here using our equation. So our y equals a minus 3x and then plus 12. And again, doing our little table here. So we can take 0, 1, 2, 3, or 4 gulps. And we're just simply plugging this in. So we do have some mental math here, or if you want to do some longhand math, that's fine also. But plugging in 0, that becomes 0. So our output is 12. And again, the output is the range, excuse me. Output is the range, which is also the dependent variable there. Excuse me. Plugging in 1, that gets us a minus 3. So 12 and a minus 3 gives us an answer of 9. Plugging in 2, that gets us minus 6. So a 12 and a minus 6 leaves us with 6. Plugging in 3 gives us a minus 9, and plus 12 gives us 3. And then at 4 gulps, we're going to get a minus 12, so there is going to be nothing left there. So identifying the domain, the independent. So our domain here, I'll just write it as domain. And sometimes you'll use brackets here as well. 0, 1, 2, 3, or 4 represents our gulps. And the range with that was 12, 9, 6, 3, and 0. So our domain and our range. The independent, kind of think of it as individual, I guess maybe that might help you. And then the dependent, the range. This depends on someone else, if you want to think of it that way. Thank you, ladies and gentlemen.